So in section 2.4, we're going to continue our study of descriptive statistics. The topic of 2.4 is measures of variation, measures of spread. Here's the learning objectives. Measures of variations, also called measures of spread, are numbers that measure how spread out a data set is along the x-axis. The four common measures of spread we can find for quantitative data set are the range, the variance, the standard deviation, and the interquartile range. The interquartile range is given in section 2.5, the next section. The range of a data set is just the difference between the maximum and the minimum data entries in the set. Example 1. A corporation hired 5 graduates. The starting salaries for each graduates are shown below. Find the range of the starting salaries. Well, it looks like the maximum is 47,000, that is, and the minimum starting salary was 38,000. Or $9,000. So one of the measures of spread, or the measures of variation for this data set with the 5 starting salaries, is the range, and the range of the data is about $9,000 wide. So if you had to draw a graph, dot plot maybe, for the data, what would that look like? Well, so there's your dot plot for your data set. And you can see that this is, of course, the salaries in thousands, and the range is, of course, this distance here. It's 9,000. So that's the range, and the range is one of 3 measures of variation presented in this section. What we'd like to do is take a look at the formula for standard deviation. And we want to be able to wrap our heads around the concept of what standard deviation for a data set is. So to do that, we begin by talking about the deviation value for a particular number in the data set. That's, of course, just the distance or the difference between that particular data entry x and the mean of the data set. So if you happen to have a population data set, and you want to find the deviation value for a particular number in that set, you're going to use this formula here. The deviation of x is just that number minus the population mean. If, on the other hand, you have a sample data set and you want to find the deviation of one of the numbers in that set, you use this formula here, that the deviation of x is that number minus the sample mean. Let's take a look at this example 2. Find the deviation of the starting salaries from example 1. So we start with a list of x values, that's the salaries. The starting salaries of the 5 individuals who got hired, and to find the deviation for each one of those, let's go ahead and assume this is a census or population data here. So to find the deviation for each one of those starting salaries, we're going to use this formula here to subtract each one of those numbers from the mean. So let's go ahead and find the population mean for that data set. Recall the formula for mean. That just has a sum up the data entries, sum up all the x values, and then divide that by the population size And of course we know the population size is 5. There's 5 measurements in the census there. And that ends up being 42. Of course, that's $42,000. So the average starting salary amongst the 5 individuals who got hired was a $42,000 initial salary. So that's the typical value in the data set, or that's the center of the data, $42,000. So let's use that number, find the deviation of each one of these starting salaries. The first deviation, 41 minus 42, or minus 1, that's to indicate that 41,000 is $1,000 below the mean, or below the average starting. The next entry is 38,000. The deviation of that starting salary is 38 minus 42, or minus $4,000. That's just to indicate that this salary, 38,000, was about $4,000 below the mean. So the deviation being minus 4 indicates 38,000 is $4,000 below the mean. Deviation for the next value in the data set would be minus 3. So to find the deviation for each one of the numbers in your population, just subtract each starting salary from the average starting salary. So we can make a few observations here, and I just wrote down a couple. This deviation number minus 4, the significance of that is just to say that an initial starting salary of 38,000 was of course $4,000 below average. You've got another salary, another starting salary, 45,000. The deviation of that value was 3, and so the meaning of that is a salary of 45,000 was just $3,000 more than the average starting salary. So what we'd like to do here is try to understand the concept of standard deviation. We know what the deviation of a particular number in the data set is. It would be nice if we could get a measure of spread that was maybe equal to the average of the deviation values. What would the average deviation number be? So to obtain another measure of spread, it was proposed that we use the average of the deviations for a data set, as this would give us a measure of how much the typical data entry deviated away from the mean, or the center of the data. The problem with that is that for any data set, the mean of the deviations will equal 0. And in fact, if you take a look at our data set, from example 1, we've got all the deviations here in this second column. Now what would happen if you tried to find the average of each one of these deviations? Well, to do that, you would have to sum up all these deviation numbers and then divide by 5. So notice what happens if you try to find the average of the deviations. When you sum this number up, sum the numbers in this column up, what are you going to get here? Well, minus 1 plus minus 4 plus minus 3, that's going to give us minus 8. And we want to add minus 8 to the sum of these two numbers, and the sum of these two numbers equals 8. So we're adding minus 8 to 8, and of course we're getting 0. So there is an issue trying to find average deviation. This is not a coincidence that it happened for this data set. So to find another way to come up with a measure of spread for a data set. It was then proposed that we take the absolute value of each deviation before we find the average deviation. The problem with getting an average deviation this way was that it almost always overestimated the value of average deviation. The decision was then made to approximate average deviation by first squaring the deviation lengths before finding the average. This is called finding the variance. Afterwards, we find the square root of the average of the squared deviations. This became the standard way of finding average deviation, hence the name standard deviation. So let's take a look at your formulas here for population variance and standard deviation. So the first formula here, population variance, this is actually the formula for the average of the squared deviations for census data. However, the units of variance is equal to the units of the data raised to the second power. For example, if x is in dollars, if your data units are in dollars, then the units on variance will be dollars squared, since when you go to find the variance, you'll have to square each deviation, which will be in dollars. You will indeed square the units as well. So to get a measure of spread that approximates average deviation and has the same units as the data, we then take the square root of variance to get standard deviation, or population standard deviation. We're going to use sigma, the Greek lowercase s, as the symbol representing the population standard deviation. We're going to use sigma squared as the symbol representing the population variance. We're going to use s, the Roman lowercase s, as the symbol representing sample standard deviation. And we're going to use s squared as the symbol representing the sample variance. The numbers sigma and sigma squared, those are called parameters, since they're numbers that come from a population data set, while s and s squared, sample variance and sample standard deviation, those numbers are called statistics, since those numbers are taken from a sample data set.